China's long-anticipated Y-30 medium military transport aircraft appears to have crossed a major threshold with the emergence of flight footage dated December 16, 2025, first highlighted by aviation analyst Rupprecht Deino. If verified, this would mark the program's first confirmed flight activity and signal that China has finally transitioned the Y-30 from concept and mock-ups into a flying prototype. The appearance of the aircraft comes after more than a decade of intermittent reports, shifting specifications, and uncertainty, making this development particularly significant for observers tracking China's airlift ambitions. The Y-30 is intended to occupy a critical middle ground in the People's Liberation Army Air Force transport fleet, bridging the operational gap between the Y-9 medium transport and the Y-20 strategic airlifter. China's existing airlift structure has long suffered from this capability gap, where the Y-9 lacks sufficient internal volume and payload for many modern military vehicles, while the Y-20 is often too large and costly for routine tactical missions. With a planned payload of around 30 tons, the Y-30 is positioned to offer a balance of lift capacity, range, and runway flexibility, aligning it with international aircraft such as the C-130J Super Hercules and placing it just below the Airbus A400M in capability. The origins of the Y-30 are closely tied to the limitations of China's earlier transport aircraft. For decades, the backbone of Chinese military transport relied on the Y-8 family, derived from the Soviet era and 12. While robust, the basic airframe imposed constraints in cargo bay width, height, and overall adaptability. The Y-9 introduced improved engines, digital avionics, and reinforced structures, but it remained fundamentally constrained by the Y-8's fuselage geometry. As the PLA ground force began inducting heavier and wider-wheeled armored platforms, particularly the Type 09 family and associated logistics vehicles, the inability to accommodate these loads without disassembly became a growing operational problem. The Y-30 concept emerged as a response to this challenge, prioritizing cargo bay cross-section alongside payload capacity. Unlike earlier Chinese transports and even the C-130 series, the Y-30 is described as having a noticeably wider fuselage designed to carry modern wheeled armored vehicles in drive-on, drive-off configuration. This design philosophy reflects a broader global trend in military airlift, where internal volume and cargo geometry are increasingly valued over raw payload figures alone, enabling faster deployment cycles and reducing reliance on heavy strategic airlifters. Public awareness of the Y-30 increased significantly during Airshow China in Zhuhai in November 2014, when a scale model of an undisclosed medium transport aircraft was displayed. The model featured a high-mounted wing, a T-tail, for turboprop engines with large multibladed propellers, and body-mounted landing gear with tandem wheels, a configuration associated with heavier medium transports optimized for rough field operations. At the time, Chinese sources described the aircraft as being in an early conceptual phase, with no final decisions on propulsion, materials, or detailed performance targets, but the overall configuration suggested ambitions well beyond a simple Y-9 derivative. In terms of size and weight class, the Y-30 is frequently associated with a target maximum takeoff weight of approximately 80 tons, placing it at the upper end of the medium transport category. Its projected payload of around 30 tons would significantly exceed the 19 to 21-ton range typical of the Y-9 and C-130J, while remaining below the A400M's roughly 37-ton capacity. This positioning allows the Y-30 to serve as a workhorse for regional lift, rapid reinforcement, and disaster response missions, while retaining the ability to operate from shorter and less prepared runways than jet-powered transport such as the Embraer C-390 or Japan's C-2. Propulsion has remained one of the most debated aspects of the Y-30 program. Early reporting consistently pointed toward a 4-engine turboprop configuration, with candidates such as the WJ-16 and the more powerful WJ-10 engine, the latter reportedly delivering around 5,000 kilowatts per engine. In aggregate, this would give the Y-30 a higher total shaft power than the C-130J and bring it closer, in relative terms, to the A400M, although still below the European aircraft's 11,000 shp class engines. Such a configuration would emphasize short takeoff performance, fuel efficiency at medium speeds, and the ability to operate from austere airfields. At the same time, Chinese studies reportedly examined a turbofan-powered alternative, drawing conceptual parallels with the KC-390. In this scenario, the WS-20 turbofan has been mentioned as a possible engine option, although it is primarily associated with heavier aircraft like the Y-20. A turbofan-powered Y-30 would prioritize higher cruise speed and faster response times at the cost of increased runway requirements and potentially reduced rough field capability. The coexistence of these divergent studies suggests that the program underwent multiple design trade-offs before converging on a final configuration, which may now be revealed through flight testing. Performance estimates for the Y-30 have varied widely, but several figures appear consistently across different sources. Maximum speed is commonly cited between 600 and 700 km per hour, faster than legacy turboprops like the N12 but slower than jet-powered transports that cruise above 800 km per hour. Range estimates of 6,000 to 7,000 km with payload would exceed those of the C-130J at similar loads, while remaining well below strategic airlifters such as the Y-20. Other recurring figures include a full-load combat radius above 3,000 km, endurance exceeding 12 hours, and accommodation for more than 110 troops or a mix of personnel and vehicles. Short takeoff and landing performance has also been emphasized in discussions of the Y-30, with cited runway requirements of around 800 meters under certain load conditions. This capability would allow the aircraft to support forward bases, island outposts, and high-altitude regions, aligning with PLA operational needs across the Indo-Pacific and Western China. Early design discussions also referenced the use of composite materials to reduce weight and improve corrosion resistance. Although the final balance between metal and composite structures has not yet been confirmed, the development timeline of the Y-30 has been marked by repeated delays and evolving priorities. Initial projections in the mid-2010s suggested a first flight around 2020 if the program received timely approval. Subsequent narratives introduced additional layers of complexity, including references to an intermediate transport sometimes labeled Y-19 and speculation about heavier future platforms such as a Y-40, all competing for funding and industrial resources. From around 2022 onward, reports increasingly pointed to renewed activity by Aviation's Shaanxi aircraft division, with expectations of a prototype flight by 2025. The appearance of flight footage dated December 16, 2025, closely aligns with these later expectations and suggests that the Y-30 has finally entered an active testing phase. However, many questions remain unanswered, including the final propulsion choice, precise performance figures, production timelines, and export intentions. If the program proceeds without major setbacks, the Y-30 could become a central pillar of China's tactical airlift capability and a serious competitor in the global medium transport market, reshaping how the PLA moves troops, vehicles, and supplies in both military and humanitarian operations.